Hi, I'm Maureen Pilcher. This is my science experiment for my PBL project. I'm experimenting to see how the material science of thermodynamics affects the small latex wall of a balloon. This balloon has water and air in it. In the bottom there's water. This one there's only air, and we're gonna light these two candles and see which one pops, or if either of them pop. They're the same height. Alright. Mom's gonna start the clock as soon as I move them. 3, 2, 1, start.
Relight it.
I don't know what just happened.
Oh, your balloon popped. And
Did
it's
it?
blowing air out of the
Oh,
bottom.
that is what happened. It popped. Like it went out suddenly. Yeah, look.
It's blowing air.
Kill it. No? Look. Demonstration showing air coming out of the balloon. As you can see, I can't even light my lighter because there's air. Ah. This one's... Huh?
Talk about that one.
This one over here has just a few drops. You can't even see it unless I move it. This one has a few drops in the bottom, also with air, as you can see. And what's happening, the reason why this one popped, which is what happened when this went out, and this one didn't, is because at the bottom here, right below the candle, is a collection of water, and when heat rises into the water, it actually disperses amongst that area that the water is touching. So everywhere the water is touching is actually equally distributing heat around it. So it's not just focused on one point. Like here, when the air wouldn't conduct around the space, it was all just on one spot. So it got a hole in it, like that. Whereas opposed to this one, where it's equally distributed, it's not going to find a spot. And this isn't going to pop until that entire surface of water gets hot enough to actually melt through the balloon, which will take a while. So,
Can you get a little bit? Can you push it down just a little bit closer without touching the flame and see if it makes it pop?
try not to smother the flame here.
Are you touching it right now?
Yeah, I am. Right now I'm actually touching the flame with the balloon and it's still not popping. If you want to take a look where it's blackened, that's actually really hot.
The balloon is hot.
Yeah. That entire area, if you feel it, the whole area where the water was is warm. But there's no particular super hot spot because it distributes throughout that. If you come over here and look down, you can see a ring about that big of water, only about that deep in the very bottom, and that's
How
keeping
deep?
it. What?
Show me again how deep.
Right here in the bottom, there's a hole. There's just a spot that big and about that deep of water that's protecting this balloon from popping because it's distributing throughout that space, only about that big. Honestly, I don't think this is gonna pop. Look, you can see I'm about to touch the flame to the balloon. Still safe and sound. Now, if I was to move this candle to a spot where the water wasn't, Well, we'll see what happens. About to make a mess is what we're about to do. That'll happen. Paper towels.
And that took 4 minutes and almost 20 seconds.